Question 334, increasing triplet subsequences. So let's jump to the question. The question is saying giving an integer array nums return true if there exists a triple of indices I, j, k such that I is smaller than j, smaller than k, and nums I is smaller than nums j, and nums j is smaller than nums k. If no such indices exist, return false. So what we're going to do here is like we're going to return either true or false if the condition exists or not. So here in this example, as you see, what we are looking for is consecutive decreasing order, and like we need I is smaller than j, j is smaller than k. So here if we check, okay, 1 is smaller than 2, 2 is smaller than 3, so we have the condition valid here. So even like we have 3 is smaller than 4, 4 is smaller than 5, but all we need is like 3 consecutive increasing number. And for example, here we have another example is like 5 is it smaller than 4? No, it's bigger than 4. 4 is bigger than 3, 3 bigger than 2, and 2 bigger than 1. So this is not a valid case either. And for the last one, is 2 smaller than 1? No, it's bigger. How about 1 is smaller than 5? Yes, it is. But is 5 smaller than 0? No, it's not. It's bigger. So the condition is not valid here. How about this one? 0 is smaller than 4? Yes, it is. 4 is smaller than 6? Yes, it is. So we have 3 indices that have the condition that we are looking for. So how can we implement this in code? Let's jump to the code and see how we can do it. For doing this, we can use 2 different variables to store the first and second number, and check the condition for the third number. And the way we do it is like we iterate over the list of numbers, and we check every single number. And what we are going to do here, the magic is happening here with these 3 conditions. So we check the first number at the beginning, and if this condition was not valid, we go for the second one, and if it was not valid, we go for the third one and we return true. And in either cases, if they are true, so we're gonna update this and we go for the next number. And at the end, if we don't get to this else, we're gonna return false. So let's go through this example to better understand the solution. So we are going to assign float infinite to these 2 numbers. The reason is like there is no number bigger than this. So this way we can update the first and second variables. So let's see, we have 2 here. Is 2 smaller than float infinite? So yes, it is. So we're gonna update this to 2, and then this condition was valid, so we skip this and we go for the next number, which is number 1. And if this condition is valid, we need to update first. So is 1 smaller than first? Yes, it is. So we're gonna update this to 1, and then we go through the for loop again for the next number. And how about 5? Is 5 smaller than first? No, it's bigger. How about if it is smaller than the second number? Yes, it is. So we're gonna update second, and we go through the for loop for the next number. And how about 0? Is 0 smaller than the first number? Yes, it is. So we're gonna update this and we go for the next number. And how about 4? Is 4 smaller than 0? No, it is not. If 4 is smaller than 5, yes, it is. So we're gonna update this, and from here we go into back to the next number in the list. And here number 6, is 6 smaller than the first number? No, it is not. How about the second number? No, it is not. So if it is not, this is the else condition that we reach, and we return true for this case. The time complexity for this solution is n because we iterate over the list, and the space complexity is 1 because we are not using any extra spaces other than the variables, which is constant. Thank you.